Hi, everybody. I'm trying this a slightly new way, so let's see if it works. So we're going to do two more word problems to go along with section 12, which is applications of linear functions. So this says, a new housing community digs and fills a lake for the community. They stock the lake with fish, but a disease strikes, and the number of living fish in the lake decreases at a constant rate as the weeks pass. 12 weeks after the lake is stocked with fish, there are a total of 5,560 fish in the lake. 20 weeks after the lake is filled with fish, there are a total of 3,000 fish in the lake. Part A says find an equation for the function that gives the number of fish in the lake, f, when W weeks have passed since the lake was stocked. So, if you remember from the beginning of the semester, I told you to always read a word problem and automatically ask yourself, what is my input and what is my output? And remember, input is always the thing that needs to happen first, the thing that needs to be known first, the independent variable. So the thing that's going to happen no matter what, that we really don't have much control over. In this case, we don't have control over time. Time is going to be independent. And so this is going to be weeks, which we're going to call W. That means that my output is going to be fish. Output is always, what are you trying to count? What are you trying to find as a result? So we're trying to count the fish. So that's going to be our output. This means that all of our ordered pairs are going to be weeks, comma, fish, because ordered pairs always go input, comma, output. Do we have any ordered pairs described in this situation? Well, it says 12 weeks after the lake is filled, there are 5,560 fish. Sounds like an ordered pair to me because I have weeks and fish. So I have an ordered pair of 12 and 5560. And then I have another ordered pair because it says 20 weeks after the lake is filled, there are 3,000 fish. So another ordered pair will be 20, comma, 3,000. How do we know this is a linear word problem? Well, let's read up here. They stock the lake, but a disease strikes and the number of fish decreases at a constant rate. So the fact that it's decreasing at a constant rate means that we should be able to take these two ordered pairs and figure out a rate of change. So that's my slope. Slope is y2 minus y1, or the change in output, over x2 minus x1, or the change in input. I can call the first one x1, y1, and the second one x2, y2. And then I can substitute. This will be 3,000 minus 5,560 over 20 minus 12. That's going to give us negative 2,560 over 8, which is negative 320. So now I figured out the slope. Remember the flow chart from the previous video. I want to first find slope. So now do I have slope? The answer is yes. Then I ask, do I have the y-intercept? Neither of these are the y-intercepts. So I go to point slope form, which is y equals m times x minus x1 plus y1. And now I'm going to substitute what I have. M is negative 320. X minus my x1 is 12 plus 5,560. And it would not have mattered if you called the other point x1, y1. And all it said was find an equation So for part A, I can stop here. This is an equation. Now, go back to your original input and output. The input I was supposed to use was W, and the output I was supposed to use was F. So I'm really going to write F equals negative 320 W minus 12 plus 5560. And now I'm using the correct variables. So this would be what they want me to use with my correct variables. So now let's go to part B. Part B is asking, write a complete sentence to determine the real-world contextual meaning of slope and y-intercept. Well, slope I definitely have because I calculated it in part A. Slope is negative 320, or negative 320 over 1 if we wanted to write it as rise over run. Think about what this means. 320, negative 320 is the change in output, and 1 is the change in input. My output here is fish, so this is the change in fish over the change in weeks. So now I can say that it's negative 320 fish per week. So in a complete sentence, this is, we lose 320 fish each week. And you can phrase that a lot of different ways, okay? Remember, indicator words for slope are the word per, or the phrase for every, or each. So any of those phrases would work here. Then it says, find the y-intercept and interpret. I don't have the y-intercept yet, but I do have this. Can I simplify this to be in y equals mx plus b form? Sure I can. So I'm going to take this, F equals negative 320 times W minus 12 plus 5560. And I'm going to distribute the negative 320. So F equals negative 320W plus 3840 plus 5560. And so that's F equals negative 320W plus 9400. Now this looks like slope-intercept form. The intercept being 0, 9400. I need to phrase this in a complete sentence. So I want to ask myself, 0 what? And 9400 what? Well, again, go back to input and output. The input here was weeks. The output was fish. So how am I going to phrase this in a complete sentence? I can say at 0 weeks, or at the beginning, or at the start, any of those phrases would work. There were 9,400 fish stocked. Okay, now let's go to the second one I want to do in this video. This should be a blast from the past. We did this problem at the beginning of the semester. You guys did it in groups. You're going to be hired as a consultant at a firm for a 30-day project. The company offers you a choice of 2 packages. Package 1, get paid $1,000 more than the previous day and only get paid after you start working. Package 2, get 25 cents or a quarter to sign on and then double your payment each day going forward. Which package do you choose and why? So let's actually start with package 2 because that's how we started the beginning of the semester. In package 2, we discovered that this was exponential. Okay, and the reason that we saw that it was exponential is because if I map this out, days and pay or money, at 0 days worked, they paid me a quarter. They paid me 25 cents just to hire me. Day 1, they doubled that. So they paid me 50 cents. Day 2, they doubled that. So they paid me $1. Day 3, they doubled that. So they paid me $2. Day 4, they doubled that. And so they paid me $4, and so on and so on. But the pattern was that as I went down the Y column, for every 1 increase in input, I was multiplying by 2. This has a constant multiplier, which we called a factor. So the factor here is 2. And so if you put the whole equation together, you start out making 25 cents. So it's 0.25 times 2 raised to the x. Now let's come back over to package 1. In package 1, if I keep track of my days and my money, if I don't work, they don't pay me. So you only get paid after you start working. But on day 1, they're going to pay me $1,000 more. So that's going to be $1,000. On day 2, they're going to pay me $1,000 more. So they're going to pay me $2,000. On day 3, $1,000 more. So they're going to pay me $3,000. And then you can follow that pattern. So on day 4, it's going to be $4,000. As my days increase by 1s, my money is adding 1,000. And so the main difference between a linear and an exponential is that a linear is a constant addition or subtraction for every 1 change in x, or every constant change in x. And for an exponential, for every 1 change in x, it has to be a constant multiplier. So that's the big difference here. I now know that my slope is 1,000 for every 1 day that goes by. My y-intercept here is 0, 0, because if I don't work, I don't get paid. And that means that my equation is going to be y equals 1,000x plus 0, and you don't have to write the plus 0. So y equals 1,000x. So this is going to be my package 1 equation. And this is my package 2 equation. Now, the question was, which package do you choose and why? So remember that you're keeping this job for 30 days. So now I'm going to turn to my calculator. And I know that you may not have a calculator at home, but I sent out a link for an emulator, a TI emulator. So if you're working on a PC or a Mac, you should be able to download that. If you're not working on a PC or a Mac, you can use any free software like Desmos. And if you have any questions about that, just let me know. So we're going to use the graphing calculator here. I'm going to go to y equals. In y1, I'm going to input my package 1 equation, which is 1,000x. In y2, I'm going to input my package 2 equation, which was 0.25 times 2 raised to the x. And now I have to think about an appropriate window. So this is where domain and range comes back into play. I need to think about a window that makes sense. So am I going to work for negative days? That doesn't make any sense. So I'm going to start my x min at 0. I'm only going to have this job for 30 days. So my x max is going to be 30. The scale can be whatever you think is appropriate. So I set the scale here at 5. Remember what your output is. Your output is your money. Are you going to make negative money? No, that doesn't make sense. So we're going to start our y min at 0. How much money could you expect to make? Well, this is going pretty consistently. Every day is $1,000 more. So on day 30, I'm definitely making $30,000. I set it to $50,000 just to give us a little bit extra. And then I changed the increments to 1,000. So I'm counting by thousands. Let's see what this window does for us. So let's hit the graph. There's my line. That's package 1. And here comes my exponential shooting up, and that's package 2. So in this area, of course, package 1 is making more. There's no question here. You can even see it in the tables. But at a certain point, package 2 is going to be the better deal. And I want to figure out what that point is. So I want this intersection. So this is going to be second trace, number 5. Follow the prompts. So bring your cursor as close as you can to the point of intersection. Hit enter 3 times. And then when it says intersection, you know you're done. And so this happens at about 15.96, or we can say about day 16. So at about day 16, I wind up earning the same amount in both models. After day 16, the exponential model is way better. And that's why we chose the exponential model back at the beginning of the semester. So I hope this makes sense. Again, if you can't get an emulator or don't have a graphing calculator, let me know, and I will try to maybe make a video on Desmos or give you some written instructions on Desmos. It's actually pretty intuitive, and you can do the same exact things. You can plug 2 y equals in, you can graph them, same type of thing. So if you have any questions, let me know. I hope this video made sense, and have a wonderful day.